Have you ever felt like you're just kind of stuck in a programming rut, writing the same old code day in and day out? Well, today, we're going to dive into F#, a language that's not just about a different syntax, but about a whole new and way more rewarding way of thinking about software. This quote, it really hits home for a lot of us, right? It's that feeling of actually rediscovering why you fell in love with coding in the first place. So what is it? What's the secret sauce in F# that sparks all this enthusiasm? Let's find out. Okay, so first up, a new way of coding. And it all kicks off with this pretty fundamental shift in perspective. F# wants you to stop micromanaging the computer and start just describing what you actually want to happen. All right, this slide gets right to the heart of it. On the left, you've got the imperative style, the how. That's probably what you're used to. You're giving the computer a step-by-step recipe. But on the right, you have the F# way, the declarative style, the what. You just state your goal, like, I want the even numbers from this list. You let the language figure out the rest. It's the difference between being a micromanager and being an architect.
And this is a huge reason why developers just find F# so fun. You're way more productive because you're writing so much less boilerplate code. It's super flexible. You can build anything from web apps to data science models. And here's the key. It's a light-touch functional language. That means you get all the amazing benefits of functional programming, like super reliable and clean code, without needing a PhD in math. It's just pragmatic.
So we've talked about the why, that new way of thinking. Now for section 2, let's get down to the what. What exactly is F# and where does it even fit in?
At its core, the definition is pretty simple. F# is built for one thing: creating software that is solid, clean, and fast. And it's not some niche tool for one specific job. This is a real, general-purpose language.
And check this out. This is so important. F# isn't off on some deserted island. It is a first-class citizen right there in the powerful, mature .NET ecosystem. That means it works seamlessly with all the C# and .NET libraries you already know and probably use. You really do get the best of both worlds. So who's this for? Well, if you're a C# developer, you're going to get way more safety with way less code. Coming from Python, the syntax is going to feel really comfortable, but you'll get static typing and a massive performance boost. And for you JavaScript folks, you get all those cool functional patterns you love, but with rock-solid type safety baked in from the very beginning. Okay, this next part, this might be the biggest mind-bending shift of all when you come to F#. It is all about completely changing your relationship with the compiler. Think about it. So often, it feels like we're fighting the compiler, right? Trying to trick it into running our code so we can then go find all the bugs. In F#, that completely flips. The compiler stops being your adversary and becomes your most trusted partner, actively helping you write correct code from the start. Let's walk through this classic example. Imagine you add a new field to some data type. Boom! Step 2, your code won't compile. And your first thought might be, oh no, but wait. This is actually an amazing thing. The compiler then hands you a perfect to-do list, pointing out every single place in your code that you need to update. You just follow the list, and once it compiles again, you've just prevented a whole class of bugs from ever happening at runtime.
This is what we mean by a partnership. Those compiler errors, those red squiggly lines, they're not failures. They're a trail of breadcrumbs. And if you just follow them, they will lead you straight to the right answer. It's an unbelievably powerful way to code.
And this all leads to an experience that honestly feels a bit like magic the first time it happens. You follow the compiler's guidance, you fix the issues, you finally run your app, and it just works. For real, on the first try. The confidence that gives you is just incredible.
So how does F# actually pull this off? How does it make this happen? Let's peek under the hood at a couple of core features that make this whole style of development possible. It really all starts with the let keyword. In F#, when you bind a value, it's immutable by default. That means it's set in stone. Once you say let x equals 5, x is 5, forever. It can't be changed later. And with that one simple rule, poof, a massive category of bugs related to things changing when you don't expect them to just vanishes. Okay, you ready for a little magic trick? Here's the simple add function, where we've spelled out everything for the compiler. A is an integer, B is an integer, and the function returns an integer. It's super clear, sure, but it's also a little noisy, right?
Now watch this. We're going to get rid of all those type annotations. Look at it now. Let add AB equals A plus B. It's so clean.
It almost looks like Python or something. But you're probably thinking, wait, did we just lose all of our type safety?
Nope, not at all. Take a look at what the IDE is telling us. The compiler is like a brilliant detective. It figured out the exact types all on its own. It knows this is a function that takes an int, then another int, and returns an int. And that is the F# sweet spot. You get the clean, beautiful code of a dynamic language with the absolute rock-solid safety of a static type system.
So let's put this all together. We've got the new mindset, we've got these cool features, but what's it actually like to be an F# developer day to day? What's the workflow?
Well, a massive part of it is a tool called the REPL. That stands for Read, Evaluate, Print Loop. But really, just think of it as an interactive playground for your code, a place where you can try things out and get instant feedback.
And this little loop is what makes you so incredibly productive. You write a little bit of code, you send it to the REPL, and boom, you see the result right away. It's the perfect way to test ideas, explore some data, and just build up your logic piece by piece.
That REPL then fits into this whole larger workflow. You start on the left, exploring and playing around. From there, you move to the core of the process. You define your types first, and then you let the compiler, your partner, guide you towards the correct code. Once all those compile time checks are green, you can ship your application with total confidence because you've already knocked out so many potential problems. So what's the ultimate payoff? It's simple. You spend more of your day creating and way less of your time chasing down bizarre bugs. You feel a deep confidence in the code you write. The code is often so readable you can actually show your data models to a non-technical person and they'll get it. It all adds up to a more productive and, honestly, a much more enjoyable way to build software.
So I'll just leave you with this final thought. Imagine that feeling of confidence. If you could spend less time on those frustrating debugging sessions and more time actually bringing your ideas to life, what kind of amazing things would you build?